Okay, so in this class we'll discuss your question 37, 38, 39, 40 on your tuition note. By now it should not be so difficult because you have done sufficient introduction of this chapter. We're now in the middle of the chapter. I think this will be the last class before reflection completes. This chapter is light, class 10, reflection and refraction. We started with reflection, and reflection will complete in this class. And from the next class, we'll start with refraction of light. Okay, so differentiate 37 between concave and convex mirrors. This is important question. Suppose suddenly this question comes in exam. They tell you write 5 differences, 6 differences, 7, then we're going to have a little bit of problem, right? So in order to get ready with this, let us just divide our notebook into right and left, okay, with a margin, and at the top another line. Let us say we drew this one, and we wrote on the left side for concave mirror, and then on the right side convex mirrors, let us say. Let's do the first point of difference. Okay, so let's just start, because this is something like revision also, because we have discussed all these points previously. Let's write down a spherical, as you write you also think, mirror, a spherical mirror whose reflecting side or reflecting surface, you can also say like that, whose reflecting surface curves out inwards, curves inside, that means inwards, or inside also you can write inwards, like the inside of a spoon. The spoon that we use to eat food is called a concave mirror. Okay, write that one difference. And here for convex, following the same thing, a spherical, let's just write same statement. So we, instead of writing, we can just write a spherical mirror whose reflecting surface curves outwards, okay, curves outwards like the outside, of a spoon is called a convex mirror. So let us look at this here. Listen carefully to this. I'm holding here now a concave mirror. This side is called non-reflecting side, the side from where we cannot see the image of our face. This side from where we can see the image of our face behind this surface is called the reflecting side. If you touch that, it is curving inside right now here in my hand like the inside of a spoon, so that is called a concave mirror. But if you take this reverse mirror, this side is the non-reflecting, reflecting surface is this. If you touch with your finger like this, it bulges outwards like a outside of spoon or outside of the bowl. That is the one. I think you're getting it right. So that is the first difference you can write. Now point number A, let us write here A and A, like your tuition note, so you can refer, connect to it is here. B is here, it's C and F. That means we know by now, so I'm not writing it full. Okay, center of curvature and focus lies in front. In front means left of the reflecting surface, of the reflecting surface for a concave mirror. Okay, you need not write left if you don't want, but in front you can write. Okay, here it's C and F lies behind. That's the difference, behind. Here, this is point number B. behind, in front, behind or right, behind or right if you want to put right of the reflecting surface. That's the only difference. Now let us explain that by drawing below this, just near this. You can just draw a rough, okay, rough along with me. So draw the line first. With your pen you can do it, because by now we're quite familiar, so you can understand. We have decided that the sign convention is like this, that the non-reflecting is on the right side and reflection on the left side. And how do we search for the center of the ball? By imagining the full ball, then the center is inside, so it will be on the left. And this is the pole, and between that is F. Then here also you draw a line. How do you draw a convex? Like this, so the non-reflective is on the right. Now the ball is like this, so the center will be now on the right. Some people draw it here. That is quite stupid, because the ball is like this. How can the center of the ball be outside? Right, so this time the C is on the right, and we know this is P, between that is F. Now check here. C and F here are left side, or let's say in front of the reflection surface. Here C and F are, this side is reflecting, this side, left side, behind the reflecting surface. That's the difference. For convex, C and F are behind the reflecting surface of the mirror. For concave, C, center of curvature, and focus are in front or left side of the reflecting surface. There is a difference, right? You see? Non-reflecting side on the right, here also non-reflecting side on the right. Still then, C and F are right side, here C and F are left side. One difference, right? So, don't rub it out for you. I have to rub so that I can have space. So B. Now let's go to point C. Keep it like that on your note also, practice note also. It will help you during exam, all those diagrams and all. So point number C is, let's write it first. It has a real focus. Concave has a real focus, and we know focus is denoted by capital F. Here it, C, point number C, has a virtual focus. What do we mean by this? Just draw this quickly with me. Okay, so not so big, so quickly, and see right here. Draw your arc, or just do it with your pen. Be halfway. If it is 4 centimeters, then put your F, and then this side also. You draw one, and mark your C here. And convex means curving like this, and non-reflection this side. So this is the center, F and P. Now let us draw a ray parallel to principal axis for concave. So this is concave side. Okay, it's already written. We know the rule is it will reflect and actually go to the focus. So this reflected ray really go to the focus. See, this is a real ray. That's why this F is real, because the reflected ray is actually or really going to the F. But here you see the difference. You pass a ray, same process. We cannot pass the light ray on the non-reflecting side. You see, this side is non-reflecting, this side. So how can you pass on this side? You have to pass on this side, right? So this side is on the left. That's why you're passing left. Now this ray, which is same as this one, parallel to principal axis, you know that the light ray, this is convex now. If you put the torchlight like this and pass parallel like this, the light ray cannot penetrate a mirror. We have never seen that, so it cannot happen. It will bounce back, and it will bounce back and look as if it's coming from focus. You can draw along with me. Broken lines through the focus on the left, and right full lines like this. So this is the actual reflected ray. And this look as if it's coming from here. Focus. But the truth is, you know, no ray can pass through the mirror, and no ray can come like this. So this is reflected ray look as if it's coming from here. But it's actually not coming from there. That's why this is not a real focus. It looks as if it's coming from there, but it's not coming from there. Therefore, we call convex mirror has a virtual focus, because the focus is not real, simply because the reflected ray is actually not coming from here. It's coming from here. Here it's called real because the reflected ray is really going here. Okay, so you can, if a question comes saying why concave has a real focus, you can say parallel incident rays actually pass through the focus after reflection. Why convex has virtual focus? Because a ray parallel to principal axis look as if it is coming from the focus after reflection, as if, and here really that's the difference. Okay, so now point number D. Let us go to D. Point number D. This is the fourth point. 7 points we have on our note. Since, right down here, since a concave mirror, converges, underline that word, converges, parallel incident rays, okay, falling on it after reflection, it is called a converging mirror. It is called a converging mirror. It is called a converging mirror. Then here D, since a concave mirror diverges, underline this word, the difference is converge and diverges, parallel, okay, parallel incident rays falling on it after reflection, comma, it is called a diverging mirror. Hyphen means you can check the word same this side, okay? So here, this is comma after this, okay? Next here. So in order to understand that, let us draw a diagram because that's the easiest way to understand. So here and here, I have space up, so I'll just draw it up here. Just draw quickly a line C and then curve. Concave is like this, curving inside. This is P, this is F, and draw a ray parallel to principal axis roughly. You know this will really go to the focus. Draw a ray parallel to principal axis. It will go to the focus. Now look at these two rays, reflected rays. They are converging, no, means many rays coming together is converging. Look at the arrow. They are converging to the same point. That's why they are called converging mirror. Let's read once. Since the concave mirror converges parallel incident rays, like this, converges, falling on it after reflection. So this converging happens after the rays reflect, after reflection. It is called a converging mirror. Easy, right? For convex, you can draw with your scale if you want. Quickly, we know that C will be on the right because the curve is like this and the ball is center is this way. So F and P. Now draw a ray parallel to principal axis, and you know this ray cannot penetrate mirror. It will bounce back and look as if it's coming from F, like this reflected ray. Another ray parallel. So these two rays are parallel to each other. Parallel, and then it will look like this, look as if it's coming from here. Now look at these two reflected rays, this arrow and this arrow. They're actually moving away from each other, means diverging. So because since the convex mirror diverges parallel, see, diverges arrow, parallel incident rays falling on it after reflection, this diverging happens after reflection. It is called a diverging mirror, convex mirror. So this question is like one difference for concave convex. Also, if a question asks you why is a concave mirror form called a converging mirror, this is your answer. Okay, you don't need to give the diagram if you don't want, but this diagram drawn on your note practice copy will really help you to quickly understand D. Okay, then next point, fifth point, E. Let us look there and write it down first. It forms both real and inverted, means concave mirror forms both real and inverted, and also not only that but and also erect, real and inverted, and or it forms both real and inverted, or also virtual and erect. Real inverted, yes. Virtual erect, yes. Depending on the position of the object. Depending on where you put the object, you will get real inverted sometimes and virtual erect also possible. This mirror is the only mirror. Concave mirror is the mirror that can form both types of image, virtual erect and real inverted also. But convex mirror, it forms virtual, or you can say only virtual erect images for all positions, or for any position, for all or any, what do you want to write, any position of the object. So wherever you put the object in front of a convex mirror, the image is only going to be one type, virtual erect. It cannot form virtual, a real and inverted image. You can see this in question number 29. Tuition note, refer, and you understand. We know we've done it previous class. This one you refer. Question number 24, tuition note. And we'll see that case 6 is virtual erect. Case 1 to 5 is all real inverted, proving that this is true, right? Now last points, F. Now you will see here, when it forms virtual, okay, virtual and erect image here means in the case of concave, when it forms virtual erect, is always magnified, means always bigger than the object. That's why when you put your face between P and F, you're getting virtual erect image of your face bigger than your real face, right? So it's magnified. But here, it also forms virtual erect only, but virtual erect image formed is always diminished. For convex mirror, the image is always virtually erect, but the size is always smaller than the object. So a question may come, this is F. Okay, so 5, 6, this is the 6th point. So a question may come saying, how can you differentiate between, okay, we can just write that question if you want. How can you differentiate? How can you identify? Let's do in practical terms. Identify concave and convex mirrors without touching them. So you can write here. Extra question, okay, this one is extra question. Now you see, if you touch, that is very clear. If you touch the reflecting surface, it's like inside of spoon, curving inwards is concave. I touch now, I can see this curving outside, really curving outside, so this is convex, very easy. But if they say you should not touch the surface, then what do? You can bring the object close to the mirror. Then if you see an image bigger than this pen, surely that is concave, because concave can form virtually erect, magnified. But if you bring the pen here, and it's smaller than the pen, you didn't touch the surface, but just looking at the image, smaller, anywhere you put the image is smaller, and this is the one, virtually erect image is always diminished. That way we can, this one, so answer you write down, bring an object close to the mirror, the one we do not know yet, full stop. If image is magnified, it is a concave mirror. Full stop. But if image is diminished, means smaller than the real size of the object, it is a convex mirror. Full stop. And then you can write, this is how we can identify concave from convex mirror without touching the surface. Okay. Next, the extra question. So we have done 37, 38, let us go. 38 is few questions before we end the portion on reflection, and we're going to go to refraction in the next class. So next question is question number 38, and 38 is, what is mirror formula? What is mirror formula? Write the answer first. 1 by V plus 1 by U is equal to 1 by F, where, okay, V represents image distance, U represents object distance, means the distance of the object from the mirror, and F represents the focal length. This formula is called mirror formula. Write that first. And you can write here the answer. The formula that gives the relationship between U, V, and F. You can explain it if you want. Object distance, image distance, focal length of a mirror is called mirror formula. It's called mirror formula. This formula that we've written first. Okay. Now here, if I put here my face in front of this convex mirror, the distance between P means mirror and my face is called object distance. And right now I can see an image of my face virtually right behind. The distance between the mirror and that image is called image distance. And you know focal length of the distance between P and F, right? We've done before also. So that is the mirror formula. Next question, 39. Okay, 39 on your tuition note. Even if you don't have tuition note, it's fine. Just follow by writing and you'll get all the question answers. What is magnification? Magnification. Okay, what is magnification? For spherical mirrors. For spherical mirrors. These are just quite easy. Let's just write it down. So M here, this is M, okay? M. So we can write down ratio, the ratio of the image height or size, which is denoted by usually HI, to the object height or object size also you can write, object height, HO, for a spherical mirror is called magnification. So there is nothing much to explain here. This is called magnification. Magnification is simply ratio means division. HI divided by HO. Okay, so your formula will be therefore, you can write here, that is M. You write here M, so we don't have to abbreviate anymore. Equal to size of image by size of object, or height of image by height of object. So this is a ratio. So M will never have unit because height by height means division of same type. So it will be centimeter divided by centimeter height. So unit will be cancelled. Ratio means division of same type. Okay. For example, rupees 10 by rupees 100 is a ratio because money divided by money. But rupees 100 divided by 20 students This is not a ratio because this is money and this is number of students. Yeah, both are division, but this is division of different types of things. Division of same type of unit is ratio. Okay, this is not ratio. Okay, now let us go there. One more last question. Question number 40. Define. These are all on your text, so it's important, but not hard. It's something like we just need to understand, or we need to know. Not much to explain. Magnification for spherical mirrors. Magnification for spherical mirrors. Okay. Magnification for spherical mirrors. Excuse me for a few seconds. Let me put some ink. Magnification for spherical mirrors. In terms of, if they ask you like this, in terms of V and U. Now this is the, if they did not tell you anything, you have to define like this, HI by HO. But if they specifically told you in terms of V and U, there is another possibility. So you write here, magnification for spherical mirrors may also be defined. Okay, may, another way of defining it, may also be defined as image distance V divided by object distance denoted by U with, but you need to very clearly know this one, with a minus. For mirror, it is minus sign, is the minus sign in front of the formula. So what do we mean by this? That is, M is also found to be equal to minus V divided by U. Okay, so if it's in terms of V and U, we have to define it like this. So that concludes your portion for this class. From the next class, we're going to go to refraction of light. As we said, reflection is the phenomenon by which a light ray is bounced back by a mirror in the same direction. When it strikes the mirror, it bounces back. But what is refraction? Let us see in the next class. Refraction is also a phenomenon of light, but it is going to be different from reflection, and we'll learn what is refraction from the next class. Okay.